Hello everyone, welcome to iQuanta. My name is Nitin. I'm sure all of you are doing great. Guys, the second video of ratios. In the first video when we had met, we had discussed the basics of the ratios, basic concepts and also important applications. In this video, we'll continue with the concepts of the ratio with some application. Also, we'll start the second part of this chapter, which is called the proportion. So let's start the video. Guys, the first concept here is about the compounded ratio. So what is compounded ratio? It's very simple. What do we do, guys? We find the compounded ratio of at least two ratios. So we do what? We find out the product of all the antecedents of the different ratios and also the product of all the consequents of the different ratios, and then find the ratios, find the ratio of those products. For example, it says the compounded ratio of A is to B and C is to D, right? So first we find out the product of all the antecedents, which are A and C in these two ratios, right? So this should be A into C. And then we also find the product of all the consequents, which are B and D in these two ratios, and then we just find the ratio of them. Now the example is based on that is a compounded ratio of 3:5 and 7:6. Okay guys, so we find the product of the antecedents and also the product of the consequents, and then the ratios of them. So here you see 3 and 6 having common with them, so 3 2s are 6, which you can say, and then it will become 7 is to 5 into 2, which is 10. Alright guys, so this is how we can find the compounded ratio of these two ratios. We can find the compounded ratio of more than two ratios as well in the similar manner. Now the second thing is the duplicate ratio. What is duplicate ratio, guys? We just do what? We find the square of all the terms given to us and then the ratios of them. For example, we have to find the duplicate ratio of A is to B, finding the square of antecedent, finding the square of consequent, and then the ratio of them. Simple. Okay, the example, duplicate ratio of 3:4. So this is what we can say 3 squared is to 4 squared, and that should be what? 3 squared is 9 and 4 squared is 16. Simple as that. Similarly, the triplicate ratio is what? In duplicate ratio, we found the square of the terms. In triplicate ratio, we'll find the cube of the given terms. So it must be what? A cube is to B cube, right? Simple. Now the example is of the same 3:4. Duplicate ratio of 3:4, that means the cube of 3 is to cube of 4, which should be nothing but 27 is to 64. A simple example, right? Similarly, guys, we have two more kind of ratios which are called subduplicate and subtriplicate. So subduplicate is nothing, you can say just the reverse of duplicate. Guys, in duplicate ratio we found the square. In subduplicate ratio we're finding the square root of them. So if you have to find the subduplicate of A is to B, it should be what? See, square root of A is to the square root of B. Simple as that, right? Similarly, if we write the subtriplicate, this is a reverse of triplicate. In triplicate we found the cubes of the terms. Here we'll find the cube root of the terms. So it should be A raised to power 1 by 3 is to B raised to power 1 by 3. Simple as this. Now guys, the examples, subduplicate ratio will be what? So we have to do what? We have to find the square root of these terms. Similarly here, the cube root of these two terms when we have to find the subtriplicate. So the terms we have taken are 64 and 729. Now guys, 64 you can say is nothing but 2 raised to power 6, and 729 is 3 raised to power 6. Now if we have to find the subduplicate, so we can say what? Subduplicate means the power half of the terms, right? Okay. Similarly, if you have to find the subtriplicate of them, so that means power 1 by 3 of them, right? First 64 is 2 raised to power 6 and power 1 by 3. Similarly, 729 is 3 raised to power 6 and power 1 by 3. Now we all know the basic properties of indices, that power on power is always gets multiplied. So here we can say 6 into half is nothing but 3. Similarly here 6 into half is nothing but 3. That should be how much? 2 cube is 8, 3 cube we can say is 27. Same comes here, it should be 2 square into 3 square, right? 2 square is 4, 3 square is 9. So this is how we can find the subduplicate and subtriplicate ratios of these two examples, right? Now guys, a very simple question based on the subduplicate ratio. The question says that if the subduplicate ratio of 225 is to 144 is x is to 4, then we need to find the value of the x, right? Now guys, how do we find the subduplicate ratio? I just told you in the last slide, we find the square root of the given terms in any ratios, right? So here the subduplicate of this ratio should be what? We do the same process, the subduplicate means the square root of the given terms of the ratio, right? So 225 raised to power half is to 144 raised to the power half. Again, 225 raised to power half means 15. We all know, 15 square is 225. Similarly, the square root of 144 is 12. As we all know, the square of 12 is 144, right? Now guys, if we try to simplify this ratio, so what shall we get? Both the terms are the multiple of 3, so it should be 5:4 after solving, right, after simplifying. And we are given this ratio is actually x:4, so this has to be, x:4, so 4 will be cancelled, and we can say the value of x has to be nothing but 5 in the end, right? So guys, we had to find the value of x, which came as 5 in the end. So this is how we can solve this simple question, right? Now guys, coming to the next part, now I'll be discussing some word problems, because ultimately, in the exam, they ask the QT in the form of data interpretation, and in data interpretation, the questions are asked in the form of the word problem. So it's very important to understand the word problems, because ultimately, the real test will be to understand the language in the exam, right? So let's come back to this question. The question says ratio of the first and the second class fares of a train is 5:2, and of the number of passengers traveling by first and the second class is 3:20. If rupees 4,400 is collected as a fare, then what is the amount collected from the first class passengers? All right. So guys, they are given 4,400 rupees as the total collection from both the classes. First, they have given few ratios. The first ratio is the ratio of the fare of a train of first class and of the second class, right? So this fare is basically per passengers, obviously. And then they have also given the ratio of the number of passengers in both the classes. So guys, we all know, the total fare, if you have to calculate, the total fare from any of the classes, it should be what? It should be the fare per passenger into the number of passengers, right? Now, luckily, we are given the ratio of the fare per passenger of both the classes, and we are also given the ratio of the number of passengers of both the classes. Now, with the help of these ratios, we can actually assume these numbers, right? Let me write this here, right? First class and then the second class, all right? So we'll be assuming both the things with the help of the ratios, right? Which two things, guys? First, the fare per passenger, and then the number of passengers, right? Okay, let me write this quickly. Now, coming back to this. So, the ratio of the fare per passenger is given to us 5:2. So, we can do one thing. Let us assume the fare per passenger of the first class is 5 rupees, and of the second class is basically 2 rupees. Simple. Now, what about the number of passengers of these two classes given to us 3:20? So, number of passenger of first class, let's say, is 3, and of the second class, let us assume as 20 over here, right? Now, we can do one thing to find the total fare. We do what? We just multiply this, right? So, what about the first class, guys? Okay, let me write this here, right? The total fare of the first class should be what? Fare per passenger is 5, number of passengers is 3. It should be multiplied to give us rupees 15. And guys, remember, this is all being the assumption, right? This is not the real number. This is being the assumption so far. All right. Now, for the second class, we can say what? Fare per passenger we assume as 2, the number of passengers assume as 20. So the total fare has to be 40, right? Now, what should be the total fare combining, both the classes? So that, according to the assumption, is how much? Is rupees 55, but it is given to us in real equal to 4,400. So guys, this is something, which we'll be using now. The 55 rupees in assumption is equal to 4,400 rupees in the real, right? Now, dividing by 55 both the sides, it should be 1. It should be what? Luckily, this number is divisible by 55. 55 8 is 440, so this should be 80. So one of the assumption is 80 of the real. Simple. Now they're asking the question that what is the amount from the first class being collected, right? From the first class passenger being collected. So guys, first class first class passenger has given total fare as rupees 15 according to the assumption, right? So one of the assumption is 80. So what should be 15 of the assumption? So we just multiply 15 with 80. It should be how much? 15 to 80 is basically 1200, right? So this is how we can solve this wonderful question. All right. Now moving to the next problem. This is also one of the finest word problems of ratios. It says what? To divide, we just have to divide rupees 390 among the 3 passengers ABC such that 3 times the share of A is equal to 2 times the share of B, which is also equal to 4 times the share of C. We need to find the difference between the shares of A and B, right? So guys, what is given to us? First of all, we are given to us that 3 times the share of A is equal to 2 times the share of B is equal to 4 times the share of B. Let me write this. 3 times of A is equal to 2 times of B is also equals to 4 times of C. Okay, now what? Guys, there is a simple property of ratios. Let me write this here. Let's say if we are given that a upon x is equals to b upon y is equal to c upon z, right? Then we can say what? With the help of this, we can say the ratio of a, b and c has to be x, y and z, right? So we'll use this logic to solve this question, right? Now remember guys, in this concept, the coefficients are being divided from a, b and c. But in this question, these coefficients actually are being multiplied. So what do we do? If we have to use this concept, we need to have these coefficients as a denominator with a, b and c, right? So we can do one thing to find the ratio of a, b and c here. So guys, take the LCM of all these coefficients, that means 3, 2 and 4. The LCM of these three numbers actually you can say is 12. Let me write this here. The LCM of 3, 2 and 4 is nothing but 12. Now do we do what? We just divide by 12 in all the sides of this you can say equation, right? Dividing by 12, obviously the equation will not change because there is a simple property in equation that if you divide the both sides, or you can say three sides of an equation with the same non-zero number, the equation doesn't change, right? Okay, so we divided by 12. Now what it should become? See, 3a by 12, 12 divided by 3 will give us 4, okay. Then 12 divided by 2 will give us 6, and then 12 divided by 4 must give us 3, right? Now with the help of this, we can say that a is to b is to c is equal to how much? We can say this is 4 is to 6 is to 3. That's great. Now finally we got the ratio of a, b and c, and then the question will become very easy in terms of solving. Remember, the question is saying what? We have given in the beginning that 390 is divided among a, b and c, right? That means the total share of them should be 390, okay? And the final question is to find the difference between the shares of a and b. Now guys, it's very simple actually. With the help of the ratios, we can assume their shares, right? Let's say a is 6, a is 4, b is 6 and c is 3, right? We can assume this with the help of the ratio. Now what should be the total of them? We can say 4 plus 6 plus 3, which is actually 13, right? So the total of them in assumption is 13, but in the real it's actually 390, that's a key. Okay, if 13 is 390, we can just find the value of 1. 1 should be how much? Dividing 390 by 13, it's divisible actually. So we can say 1 is equivalent to 30. Now coming to the main question, they were asking the difference between the shares of a and b. Now we can do this in two ways. Either with the help of this, we can find the actual shares of all of them, right? Or we can directly find the difference, which will be actually easier. So guys, remember the difference is how much? In assumption, the difference of a and b is what? See, b is greater than a, so the difference in assumption is actually 2, right? So we just have to find that 2 is equivalent to what, right? Remember guys, 1 is equivalent to 30, so we can say 2 must be equivalent to nothing but 60. That's it, right? So this is how we can solve this wonderful question as well. The difference of them of a and b is being 60 in the end, right? Okay, so this is how we solve this question as well. Now, guys, we'll be learning, the another category of this topic ratio, which I said in the beginning as well, which is called the proportion. All right, there are a few more categories which also we'll be learning very soon. Let's first focus on proportion. So what is proportion, guys? Let me tell you the basic meaning of proportion. If they are saying that A, B, C, D are in proportion, right? So what is the meaning of this? First of all, if they are saying A, B, C, D are in proportion, then we can say what? The ratio of the first two terms is equals to the ratio of the last two terms. If this is something happening, then we can say the given four numbers are in proportion. So you can also understand, to get some numbers in proportion, there should be at least four numbers. Only then we can frame two ratios, right? Okay, because one ratio consists of two numbers, so for two ratio there should be at least four numbers with us. Let me take an example. So suppose there are a few numbers given like 10, 15 and let's say 18 and 27, right? Now let's see, are these four numbers in proportion or not, right? So guys, how do we check? Take the ratio of the first two terms and also the ratio of the last two terms, right? Now 10 is to 15 luckily is 2 is to 3, and 18 is to 27 is also luckily 2 is to 3. So yes, the ratio of the first two terms is being equal to the ratio of the next two terms. That means we can say yes, these four numbers are definitely in the proportion, right guys? They are definitely in proportion. We can definitely say this thing. All right, moving next, guys, in this we can actually name these numbers as well. Remember I said ABCD in proportion, right? So from this we can say what? A is basically called the first proportion, right? These are the names of them which we should remember because they can also be asked in the question directly, right? So A is the first proportion. Similarly, B is called the second proportion. Similarly, C is called the third proportion, and similarly, D is called the fourth proportion over here. There is one more way we can, name them. Remember, guys, there are 4 numbers, right now. Among them, A and D are the extremes, and B and C are middle of them. So we can also say that A and D are the extremes, all right, and B and C are the means. Simple, right? We can also say B and C are the means. All right, guys, so this is, another way of naming them. Now, one more thing, remember we wrote that A, B, C, D are in proportion, then A is to B is equal to C is to D. If we write this mathematically, so we have A upon B is equal to C upon D, right? Now, if we do the cross multiplication, taking D here, it will be A into D, right? Taking B over here, it will be B into C. Now, guys, what are A and D? Remember, A and D, I just told you are called extremes. B and C are called the means. So we can also say that the product of the extremes should be equal to the product of the means, because A and D are the extremes and B and D are the means. That's it. Product of the extremes is also equal to the product of the means with us. Alright, guys, so these are the basics. Now let's simply solve a very basic kind of question with the help of this. The question says that if AB, AC, BC and X are in proportion, then find the value of X in terms of A, B and C, right? So guys, AB, these 4 terms are in proportion. That means the ratio of the first 2 terms should be equal to the ratio of the next 2 terms. Simple, right? That means AB is to AC have to be BC is to X, right? If you write this mathematically, like in the form of the fractions, it's AB is to AB upon AC is BC upon X, right? So you see that AA got cancelled here, BB got cancelled here, X goes there, all right? And this C comes here. So C into C will give us C square. That means the value of X is nothing but C square, which you can see here, right? Simple things. Okay, guys, this is how we can solve this very simple question, right? Okay, now what would happen if these number of terms are more than 4 in the proportion? Is it even possible or not? Yes, guys, this is possible. Let me take you an example. Okay, suppose we have given A, B, C, D, E and F are in proportion, right? So what is the meaning of this? Remember, guys, when we had 4 terms, we said what? The ratio of the first 2 terms should be equal to the ratio of the next 2 terms. Same thing will happen here as well. That means we can say what? The ratio of the first 2 terms should be equal to the ratio of the next 2 terms, which should be equal to the ratio of the next 2 terms as well, right? That means A is to B should be C is to D should be equal to E is to F as well. So basically, this process will continue even if we are given the number of terms, but only one thing should exist, only one rule will work here. That is, the number of terms have to be even, right? I'm sure you agree with me, because every time we are taking the ratios being equal to each other, and one ratio consists of 2 numbers, obviously, so we can say what? The number of terms have to be the multiple of 2, or you can say even, right? Let me write this. Number of terms have to be even and have to be at least 4, right? At least 4. Simple. Only then we can have 2 ratios, obviously. Okay, let me put an example of this as well. Does it really is it really possible or not? So let me take the example like 10, 15, 18, 27, and we can say 32, 48. Let's check, are these 6 numbers in proportion or not, right? So the ratio of the first 2 terms means 10 is to 15 is actually 2 is to 3, right? The ratio of the next 2 terms, 18 and 27, this is also 2 is to 3. Okay, the next 2 terms means 32 and 48. Is this a ratio 2 is to 3? Yes, this is also 2 is to 3. So yes, we can say that these 6 terms are in the proportion for sure, right? Let me write this. These 6 numbers are also in proportion. Okay, so this is the basic meaning of the proportion. Now guys, coming to the next type of the proportion, which is called the continued proportion, and actually this is more important than the normal proportion. That's why I did not discuss much about the basic proportion, because this is something which is asked more in the exams, right? Now what is the meaning of this? So guys, as it is saying continued proportion, what is the meaning of this continuity here? So what happens if, let's say, a few numbers are given in continued proportion, so the consequent of the first ratio becomes the antecedent of the next ratio. Simple. Similarly, you can say the consequent of the second ratio will become the antecedent of the third ratio, and so on. So let's start with a simple example, right? Let's say we are given that ABC are in continued proportion, right? So guys, what is the meaning of it? Okay, let's understand. If ABC are in continued proportion, then we can say what? That A is to B has to be basically B is to C. As I said, the consequent of the first ratio has to be the antecedent of the next ratio. Simple. So you can see the consequent of the first ratio is B, which is also equal to the antecedent of the second ratio. Let me take an example for you. So let's say guys, if we are given the numbers as 12, 18 and 27, right? Let's check, are they following this property or not, right? So the ratio of the first two terms, 12 and 18, and the ratio of, you can say, second and the third term, right? Second term is the consequent of the first ratio and also the antecedent of the second ratio, right? So let's check, are these two ratios same or not? 12 is to 18 is actually 2 is to 3, both are divisible by 6. 18 is to 27 we can say is also 2 is to 3. They both, if you divide by 9, you will find this. So yes guys, both the ratios are being equal. That means yes, we can say that these numbers are in continued proportion. All right, that worked. Okay, fine. Now just like normal proportion, I told you the nomenclature of these terms, right? Here also we have to know the nomenclature of them. For example, we can say what, if ABC are in proportion or continued proportion, A is called the same like the first proportion. Okay, what about B? B is also called we can say it's the second proportion, the same thing. And what about C guys? C is, we can say, is called the third proportion. Simple. Alright, there is another way of naming them. We can also say A and C are the extremes, okay, and we can call that B is equal to the mean of them, right? Okay, B we can say is the mean. We can also say that B is the mean proportion, B is also called the mean proportion between A and C. We should know this as well. B is also called the mean proportion between A and C, right? Okay guys, now let's do one more thing. Remember, A is to B is B is to C. If we write this in the form of the fraction, it should be A upon B is equal to B upon C. Multiplying them, C taking here A into C, B taking here is equal to B square. So A into C is equal to B square. We can also say that B is equals to AC square root. All right. Now, if you guys remember, I just told you that B is the mean proportion between A and C, and the value of B is being A into C raised to the power half, right? Okay, if I just put it here, B is the mean proportion over here, right? So we can say what? The mean proportion between, A and C is what? Between A and C is actually B, right? And what is the value of B? The value of B is being A into C raised to the power half, all right? A very important thing. We can say the mean proportion of between any two terms is nothing but the power half of the product of them. For example, the mean proportion of A and C is what? Is the power half of the product of A and C, and then that will work for any two numbers. All right. So this is, guys, the basics of the continued proportion. Now let's try a few problems based on this. Very important, guys. The first question says to find the mean proportion between 18 and 32. I just told you how do we find the mean proportion between any two numbers, right? It's nothing but the power half of the product of them. So here we will do the same thing, multiplying them 18 and 32, and then finding the power half of this product. So guys, 18 is what? 18 is basically 2 into 3 squared. Number 1. 32 is what? Is 2 raised to the power 5. All right. Now, simplifying this more. So this is what? 2 raised to the power 1 into 2 raised to the power 5. Power should be added. 2 raised to the power 6, and this is 3 squared. Now the power half. Power and power gets multiplied again. So this must be 2 cube into 3 raised to the power 1. 2 cube is 8, and 3 is 3. It gives us 24 in the end. So guys, this is how we can find the mean proportion between any two numbers. Very simple. Okay, the second question, this is a good one, right? This question says find the number which must be added to these numbers so that the resulting numbers are in continued proportion. Okay guys, we have to find one such number which must be added to these three numbers, all of these three numbers, so that the resulting number should be in continued proportion. So first thing, we can assume that number, okay? Let x is one such number, okay? X is one such number which should be added to these three, and then the resulting number must be in the continued proportion. So guys, if x is added in all of these three numbers, what should be the resulting number first of all, right? So let me write here the resulting numbers after adding x. Okay, if x is being added to 10, the resulting number must be 10 plus x. Similarly, if x is added to 14, the resulting number must be 14 plus x, right? Similarly, if x is added to 19, it should be 19 plus x, right? And now all these three should be in the continuing proportion as it is, being given to us. All right, if these three numbers are in continuing proportion, now we can apply the same property here, right? That if three numbers are in continuing proportion, then we can say this thing, b square is equal to a into c. This is the finest results which you can use if you are given some numbers are in continuing proportion, okay? So, or you can also call it, okay, I just missed one important point, guys. Remember, a into c is b square, right? So, b is what, if you remember, b is the mean term, and a and c are the extremes. So, you can also say that product of the extremes should be equal to the square of the mean term, the square of the mean term. So, yes, we can, remember this result, which can be extremely helpful, in solving a certain kind of question, especially the question which I had, just written over here, right? So, we can say one thing, that is square of the extremes means, sorry, product of the extreme means these two terms must be equal to the square of the extreme, square of the mean, which means these two terms, right? So, guys, the mean here is 14 plus x, and the extreme here are 10 plus x and 19 plus x, right? So, product of the extremes, which means 10 plus x into 19 plus x, it has to be the square of the mean. The mean here is 14 plus x, so 14 plus x whole is squared. All right, let's see what do we get after doing this, right? So, if you multiply these terms, right, what we should get, 10 into 19 is 190, okay, then 10 into x is 10x, all right, then x into 19 is 19x, okay, and then x into x is x squared, okay. Right hand side, you can write like a plus b whole square, which is a square plus 2ab plus b squared, okay. So, first we write 14 square, which is 196, plus 2ab, which means 28x plus x squared. Okay, now you see that x squared must get cancelled out, all right. 196 is here, 190 is here, 190 goes here, it should be 6, right. Left side is 10 plus 19 is 29, and this is 28. 28 subtracted from 29, we get x. So, we can say finally the value of x is being 6. And remember, guys, we had to find that number which we had assumed as x, right. That means we actually had to find x in the end, and it came to be 6. So, we can say yes, 6 is the final answer of this question, right. Okay, now one more thing, very important. Guys, what will happen if the number of terms in continuing proportion are more than 3, right? What is going to happen in this way? Okay, as we just discussed, what happens when the number of terms are more than 4 in, normal proportion. Similarly, we have to discuss what will happen when the number of terms are more than 3 in continuing proportion, right? But what is the logic of continuing proportion? Let me take you there. The logic of continuing proportion is that the consequent of the first term becomes the antecedent of the next ratio, right? And same thing will continue actually, right? So we can just apply the same logic here. Suppose we have 4 numbers in continued proportion. Let me write this. If a, b, c and d are in continued proportion, then we can say what? Then we can say that a is to b, right? It should be how much? It should be, we can say, b is to c. As I said, the consequent of the first ratio should be the antecedent of the second. Similarly, guys, the consequent of the second ratio must be the antecedent of the third ratio. So we can say a is to b has to be b is to c, should also be c is to d. Similarly, if we had more number like e as well, then it would be like d is to e and so on, right? So this is very simple. We just have to remember the basic property of this, that the consequent of the first ratio should always be the antecedent of the next ratio. Simple as this. Let me show you one example on this particular concept. Let's say we have, we can say 24, 36, right, 54 and 81. Let's check whether they are in continued proportion or not, right? So guys, first term and the second term writing as a ratio. Now the consequent of the first should be the antecedent of the next, means 36 is to 54. Now the consequent of the third should be the antecedent of the next, that means 54 is to 81, right? Let's check, are these three ratios are same or not, right? So 24 is to 36 is being 2 is to 3, that's fine. Similarly 36 and 54, this is also 2 is to 3, this is also fine. Similarly, 54 and 81, this is also 2:3, you know. They are divisible by 12 and getting 2:3. They both are divisible by 18. And similarly, they both are divisible by 27 and we are getting 2:3 again. That means all these three ratios are being same. That means we can say these four terms are in continued proportion. All right. Okay, so yes, more than three terms can also be, you know, continued proportion, right? And this time there is no condition like the number of terms should be even or something like in the normal proportion. There is no such condition. The only condition you can say what? The number of terms has to be more than 3 or, you know, you can say equal to 3. Number of terms should be at least 3 is the only condition which, you know, lying over here, right? So guys, this is about the proportion. We finished this whole chapter. Now in the next session we will be meeting, you know, we'll be discussing the remaining categories of ratios like partnership and variation. In this video, this is all about, you know, today's video. Thank you so much for watching. I hope you guys enjoyed it. You can write anything in the comment if you like it or not. If you want us to do something else, then also you can write in the comment, right? Till then guys, take care and keep studying. Bye bye.